Slope-intercept form, day 1, notes. Always like notes, you can use them on the quiz. So basically when we're doing slope-intercept form, there's 2 parts in there that are kind of helpful to us. This m, whatever number's in front of my x here, that's where I'm going to find my slope each time. No matter what, whatever you see in front of x is going to be the slope. Okay? It's not the number and x, it's just the number. Then this b on the end, and this gives us a little bit of connection to what we just got done with, is the y-intercept. I don't have a specific place to find the x-intercept. That's why we sort of need to learn a little bit with this new one where everything's at. So when we go to graph them, we can make this a little bit easier on us. So if we're asked to write an equation of a line in slope-intercept form, and they tell me the slope, my m, and they tell me the y-intercept, my b, all I got to do is plug the numbers in and I'm done. No calculating even. So I'm like, okay, so it's y equals m, that's my slope, which is -4, x plus b plus my y-intercept plus 3. I'm done. So I'm just plugging numbers into those 2 spots right there. Finished. And I don't mind even if you put plus and negative sometime. For instance, let's say we were doing number 2. It's the same idea. My slope is m. My y-intercept is b. So I go to plug them into my equation. And I'm like, okay, so y equals m, my slope, x. You could write plus -3. That's not the way I prefer you to do it, but it would be all right. Or,
I know, but why would they have it? Why wouldn't it be 8n?
Because
I get why they have the x.
okay, what the x and the y stand for is, like, if I wanted to know a specific point on the line where it was, if I knew what x or y was, I can plug that in and I'll find the other one. I've never been quite sure why they decided to use m as what they use for slope, because you think, why don't they use s? But I guess they wanted to use that for something else, so they just chose some random value to go with. So we're just... Ooh, thank you. Oh, I should have had pause first. Uh-oh. Wow. Okay. Back from our sneezing timeout. But when we're doing any of these, I normally would just write the minus in here, because that way when I go to plot this point, which we'll get to, I just know to go down 3. I don't get possibly confused with that. So what's my equation of my next one going to look like if my slope's -2 and my y-intercept's -1? All right, y equals -2x minus 1. Because that y-intercept's always just going to be the number on the end hanging out on its own. So as long as I can keep that straight, y equals mx plus b, I can have that set. And that's all I got to do on that with writing equations. You're going to, there's lots of those floating around in these assignments. But they're not always going to be quite that straightforward with me. Sometimes, when I'm trying to find these, they may give me a graph and tell me that I've got to find it that way. So for instance, down here, you're like, okay, my first thing I've got to figure out, because there's 2 parts, I got to figure out my slope. And I got to figure out my y-intercept. Now, when I have my y-intercept, it's always going to be 0 and some number. That's how I'm going to find it when I'm looking at the graph, because when we did that with the y-intercepts in the last part, that's what they all looked like. So let's do the y-intercept part first, because that's going to be the easiest. This is kind of our directions to work with here. So let's see. Okay, which one of these is my y-intercept? The second one, because it's got the 0. So my y-intercept otherwise known as my b value, is -2, because I just want the y part of it. Okay, so this is going to cross my line at -2. Now my slope, I got to actually figure out. And that's just like what we were doing before as well. I just count to see how far I've got to go to get from one dot to the other one. But just remember with slope, it's always your up and down number is first. It's the number that goes on top. So let's start counting here. Went up 2, so that would be positive. And I'll write this out to the side too here in a minute. And so once I go up 2, if I just go right 1, I'm there now. So 2 over 1. So now I've got it like I did up here. I know my slope. I know my y-intercept. So I can do y equals. My slope is 2 over 1. Or you could just write 2 x plus this -2. I'm done. So there's just a little more work in that I've got to find those two pieces. So on this one, let's find both my pieces here. Let's see. How do we want to do this? So again, one dot to the other. It doesn't matter which way I go. I can go down and right. I can go up and left. Anybody have a preference? Down and right or up and left? You're like, no. Okay. Then I'll do it my way. I'm going to go up and left. So again, I always do my up or down first. So let's see. I went up 3. So that's positive. But then I go over 3 to get to the dot. But I went left. So is that positive or -3? Negative. And if I can reduce fractions, I need to. So it'd just be -1. Yeah. Okay, and that's my slope. And if you're not sure sometime if it reduces, the calculator can do it for you. Okay, so my B, my y-intercept. Okay. Here, you could just write -1 if you wanted to. I just like getting in the habit of making slopes fractions so when we graph them, it's a little bit easier to work with. So yeah, my B is going to be 3. There's my 0, and there's my y-intercept right there. So y equals, and like Caitlin was saying, if you just wanted to write -1 for your slope, you can. But if you want to write the fraction, that's okay too. And then plus my b. And I knew it was negative because it was going down to the right. Mr. Slope Guy taught me that before. All right, let's play with one more of these here. Let's try out number 7. All right, I'm going to find my 2 dots here. We've talked before about it doesn't matter if I go up and over or down and over. I'll end up with the same answer at the end. So let's see. My slope. What is my slope for this one if I count up and then over? I agree with your 3. 1, 2, 3. Count one more time.
6.
Once I'm here, how many is to get from here if I count over? 4. 3 over 4. It is a fraction, so we'll just leave it that way. And then again, what's my y-intercept? Which one has 0 and then a number? -5. Just look for the one that has 0 and a negative number. And then I'm ready to go. Y equals m x, and then my b. And I'm ready to go. So now, we've taken a look at putting it into slope-intercept form if they give me the slope and the y-intercept. We've looked at if they give me a graph. So now the next reasonable step is to actually start graphing these. Now, we're going to make one note here. Okay, it has to be in y equals form before we start. Right, for number 7 it is, but for the others it may not be. So that's something we've got to keep in mind. But you're right, number 7 is already. So I'm like, okay. So once I get here, and I'm not going to have to label all these when I'm doing them on mine, but if it's a note sheet, it's kind of helpful to see some of these things. So the number hanging out on the end is going to be my y-intercept. And again, my y-axis is this guy that goes up and down. So I just say, okay, well, if it's positive 1, there's positive 1. I'll put a big old dot on that point. And once I've done that, because I always do that first, now I notice my slope here, my 2, isn't a fraction. How do I make that a fraction? Put it over 1. Okay. So my slope is 2 over 1. And remember, when I'm doing slope, the number on the top represents how much I'm going to go up or down. Well, it's positive, so I'm going to go up. Yeah, whenever we're doing slope, remember, slope in its simplest form, if we think back, slope is rise over run. In other words, slope is how much I go up or down versus how much I go right or left. And we put this on Mr. Slope Guy's face before. But that's something I want to keep in mind when I'm doing this. Nope. Top number is always up and down. So I'm going to go up 2, and the 1's positive, so I'm going to go right 1. Because just like what we had before, this is basically what we put on his face. So from that first big dot that I made, I'm going to go 2 up, and I'm going to go right 1. And I always tell people, could I make a line from 2 dots? Yes, but I prefer 3, just so in case I mess something up, I'd notice it. So if I go another 2 up and right 1, then I can go ahead and connect the dots and make my line. But I have to keep what slope is straight, because if I'd have gone right and then up, I'd have gotten a different answer. So we're going to keep that handy here. So as I move on to 8, I'm like, ew. Now what am I going to do? Now it's not in y equals yet. Yes. If my job is to get y by itself, and I'm adding 3x to it, I've got to do the opposite. Now there's one thing that might get me still, so be careful. Remember, the form is y equals mx plus b. The x term's got to go first. So negative 3x plus 2. I don't want to write 2 minus 3x. There's too many things that can happen if I do it that way. So I look and I'm like, okay, which one of those numbers is my y-intercept? 2. The number hanging out on the end by itself, always the y-intercept. Positive 2, big old dot on 2. My slope, again, isn't a fraction, though. I see it's this negative 3. Yep, this time, since it's negative, since my rise is negative, I'm going to go down 3. So I start here. I go down 3. Don't put a dot yet. And then 1 is positive. I'm going to go right 1. Put a dot. Down 3. Right 1. And they all should end up on the same line.
Can we go the other way?
What's that?
Like, can we go from the 2, can we go up 3 over 1?
Up and left?
Yeah,
Yes.
can we do that?
Yep, I was going to say, one of these we were going to run out of room and I was going to do that. But yes, you absolutely can do a double opposite. Yep, do both the other way. All right, let's get one more solved for y here. Kind of goes along with what you guys were talking about yesterday a little bit. All right, I need to get the y by itself. How do I get the x out of there? What's the opposite of adding x? Subtract. Okay, now this one we're going to need to take up some space here. I'm actually going to do it up here to the right, so we got a little more room. So I've got 2y, and I have negative x minus 1. And what number's in front of x when I don't see it? 1. Okay, and I'm actually going to put that in here so I don't get confused. Right. And I got to divide by 2 to everything to get y by itself. We're just going to keep it as a fraction. You're like, oh, crap, though. I haven't had a fractional y-intercept before. That's okay. So I go, all right. My b is -1/2. So I'm like, well, where is that? Well, it's negative, so I know it's down here. And 1/2 isn't quite 1, but it's going to be in between here, in between 0 and -1. And then I'm like, okay, my slope is -1/2. Whenever I have a negative number with my slope, the negative number only goes on one of the numbers. And you can pick which one. I normally just put it on the top. So I'm like, okay, if that's the case, let's see here. So -1 would be down 1. So it's still going to be in between the numbers. That's okay. And a +2 is right 2. So down 1, right 2. And I got to connect the dots. So when we're doing these, I always want to do my y-intercept first and that second. All right, to the back for the 2 weird ones. And then we're just going to do number 12, because I do want to get one story problem in here. Just one, though. Okay, oh, y equals 3. Now, wait a minute. I remember this from before. I don't see x's anywhere. How the heck am I going to do this? Oh, shoot. Let's see. Mr. Slope guy. What's a line going to look like that just has y equals in a number? Which way does it go? Horizontal. So what I do is I go to where y equals 3. I put a dot. And y equals is always just going to be a horizontal line, a side-to-side line through that point. So with y, always side to side. Mr. Slope guy says it too. It's where you find his smile on his face. And then, right, the slope would be 0. That's true. Nice. But now when it changes to x equals, that's Mr. Slope guy's nose. So here's my x. I go to -2. And I'm going to draw a vertical line because the slope is undefined. And then the last thing we got on here, one story problem. I will let you off the hook on 13 and 14 here. Wade's grandmother gave him $100 for his birthday.
What are those?
This?
No, the red dots.
The red dots? The red dots are just the area that I can be doing my videoing in.
Oh, that's cool.
Yeah. So Wade wants to save his money to buy a new MP3 player. Oh, this must be a little old. That costs $275. Holy cow. Each month he adds $25 to his MP3 savings. Write an equation in slope-intercept form for M, the number of months it will take him. Okay, here's how this is going to work. Here we have something that occurs one time. I'll explain in just a second here. This says that the total, how much he's going to need at the end, is going to equal the regular, which I just call an addition, which is going to go to x, plus what he gets one time. So basically, what we're going to be doing is we're going to be trying to figure out how long is it going to take Wade to save up this $275, given the information. Whatever happens one time, his birthday will happen once each year. So the $100 he gets is going to go on the end of my equation, the plus 100. It's not like he's getting $100 every week or every month. It's just on his birthday. And it says here that at the end, the total is going to cost $275. Okay? And sometimes this may just be Y. Okay? How much money is he adding each time to his savings? $25. But it says each month. So what the X would represent here is each month that he's doing it. So if I wanted to come up with a way of looking up how long it would take him, and I'll even show you this. I wasn't going to do this yet, but I want you to see where the application comes in here. Okay, this is the equation of how long it would take Wade to do this. Now, if you wanted to figure out how many months it took him, here's how I could use the calculator to do it. And we'll get into this, but on the calculator, I could type in that equation. Oops. And I can graph the line. Now you're like, well, what's that tell me? I can't even see what's going on here. Here's how it helps me. There's a way to get a table on here, and basically it's going to tell me how much he has after each month. And if I want to see how long it's going to take him to save up $275, I could let the calculator tell me. And it tells me it's going to be 7 months. I don't even have to do algebra. I just let the calculator do the work. And we'll learn some more about that too as we do more with the graphing. But our thing is just whatever I put in each time gets the X, and whatever I get one time has this. So here's now what we're going to do. Because again, this is a note sheet. Keep this in a safe spot, because then when we do the quiz on graphing, you have it. It's ready to go. So, we got to do some stuff to be able to learn it. We got to get some practice. Speaking of practice. So like I mentioned at the start, this assignment is our last one for homework check 12. And you'll notice there's a lot of similarities with these and the ones we were doing on the note sheet. For instance, you look at the first two, they look a lot like what we were doing in 5 through 7 on the notes. So sometimes just giving myself an idea of where to look for the help can be helpful. Write an equation of the line in slope-intercept form. Okay, so this is like problems 2 through 4 was in the notes. You're like, oh, I got examples of all this stuff. This isn't going to be anything terrible. Graphing, we did that. Seven through 9 on the bottom there in the notes. We got some examples of that. And they look just like this, so that should be helpful. And then I think I got something I'm going to be able to trim on the back here. Let's see. Okay, we've got, and those are still running the same way. And then the last two are just getting me set. Now let me do this with you. Let me do number 20 with you, and then I'll have you do number 21, because they're kind of similar that way. So let's see here. A rental company charges $8 per hour. So for every hour I'm renting it, I got to pay them $8 for a mountain bike, plus a $5 fee. It doesn't say hourly, so this looks like it's a one-time fee for a helmet. Write an equation in slope-intercept form for the total rental cost for a helmet and bicycle for T hours. Now, I'm not as concerned about their fancy variables. Whenever I see something that says per hour, per day, per whatever, that's where my X is going to be. So when I go to make my equation, wherever the X is, wherever the per something is, that's the one that goes with it. Wherever the one-time cost is, that's the number that goes on the end as my Y-intercept. So here's how this would go. When it says what would be the cost for 2 helmets and 2 bicycles for 8 hours, I say, okay, the bicycles are $8 an hour normally, but that's for one bicycle. If I have 2 bicycles, how much am I going to be spending an hour? Nice. 2 bicycles would cost me twice as much. So it would be 16x. If 1 helmet cost me $5 to rent, how much is 2 going to cost me? How much are 2 helmet rentals going to be? $10. So here's what I would do. I'd be like, okay, so y is going to equal 16x, because I'm renting 2 bicycles, plus 10, since I'm renting 2 helmets. To figure out the 8 hours, I just plug in the 8 for x. So it's going to be 16 times 8 plus 10. Let's see here. 16 times 8. It's 128 plus 10. I'd be spending $138 for these 2 helmets and these 2 bikes. But that's the setup that I'm doing with these. Most of the time, it'll just set up like your first one. They threw a little bit of a twist at us there, so I wanted to do that one with you. But otherwise, you're just following the examples that you've got to work through the rest of the questions. There's no other surprises that are being thrown at you, okay? But this needs to be ready for Thursday for the homework check. And if some of you still need to be looking for some of the sheets, I'll get that up here in just